All right, today we're going to begin geometry by talking about points, lines, and planes. And we don't really mean points, lines, and planes as shown in the pictures here. And you'll see them defined in just. So in geometry, a point is really a theoretical or an imaginary thing. It has no size. So think of it just as a location somewhere out there in space. It's represented by a small dot and a capital letter. So here on the bottom of the page, you see this little small dot and a capital letter. We would call that point A. It's always a capital letter when you're referring to a point. All geometric figures are made up of a series of points. A line, on the other hand, is a series of points that extends in two opposite directions without end. And that without end is very, very important. So you see with a line, we have these two arrows on either side. You can name a line by any 2 points on that line, and you name it by placing a line symbol over the letters. So for instance, if I wanted to name this line, I could name it line AB. Those are 2 points on the line, and I would put this symbol on top of it, making sure I put arrows on either end. But I can name it with any 2 points. So I could also name this line AC, or I could name it BC, but it goes in opposite directions without end, so I could also call it BA or CA. So there's lots and lots of different names that you can give to a line. You can also name a line with a single lowercase letter. So if this was labeled with this L, I could call this line, line L. So if I said, can you tell me the length of this line? Would you be able to take a ruler and go up to your computer screen and measure this line? No, because remember, a line extends in opposite directions without end. So if it doesn't have an end, then I can't measure it. All right, let's take a look at an example. How many points are shown in the diagram? Well, remember, points are designated with capital letters, so let's count how many of the capital letters we see. There's H, M, N, O, J, K, L, and I. So there are 8 points shown in this diagram. Remember that the smaller case or the lowercase letters R, Q, and P actually designate lines, so those would not be considered points. Name a line that contains point J. So first thing, you're going to locate point J. This would be the line that would contain point J. And there are more than one correct way that you could answer this question. You could say JK, naming it with those 2 points. Again, making sure that you put a little bar with 2 arrows on top to designate that it is a line. You could say KL. You could say LJ. Or you could name it line Q. Any one of those answers would be correct. Give 3 different names for line HN. So again, let's locate line HN. You could name it NK. You could name it NH. You could name it line R. And there's other possibilities, but that would be one example of 3 different ways that you could name line HN. So let's look at some more vocabulary. Collinear are points that lie on the same line. Notice that the word line is in collinear to help you remember what it means. So if I said name 2 collinear points, well, here you have this line, and you could say FB are collinear or BE are collinear. But remember, you can put a line through any 2 points. I can make a straight line through any 2 points. So really, any 2 points would be collinear. I could say that AC are collinear or BD is collinear. So just because I can't actually see the line doesn't mean that it doesn't exist. There is a line through any 2 points. If I said name 3 collinear points, then that would be a little different. I could say point F, B, and E are collinear because they all lie on one straight line. I could take my pencil and place it over those 3 points, and it would cover all 3 of those points. Non-collinear points are points that do not lie on the same line. Again, there is the word line in the word, but the non in front of it tells you that they are not on the same line. Can you name 3 non-collinear points? Well, we could say F, A, B are non-collinear. I couldn't take my pencil and place it on all 3 points at once. So now that we've talked about points and lines, let's talk about planes. And again, I don't mean an airplane. In geometry, a plane is defined as a flat surface that extends in all directions without end and has no thickness. So again, this is more of an imaginary thing than a real thing. We designate a plane as a parallelogram in geometry, but you can think of it as any flat surface. The top of your desk could be a plane. The top of a front of a book could be a plane. You name a plane either by a single capital letter, as you see on this diagram here on the left, we call this plane P, or by naming it by at least 3 non-collinear points. So if these points were all in one straight line, I wouldn't really be designating a plane, I'd only be designating a line. So I need 3 non-collinear points in order to name a plane. So as you see on this figure on the right, I could call this plane ABC. Remember, any 3 points can make up a plane. So just like any 2 points would make up a line, any 3 points would make up a plane. And just like we have collinear, we have coplanar, which are points and lines that lie in the same plane. And we have non-coplanar, which are points and lines that do not lie in the same plane. All right. Through any 3 non-collinear points, there is exactly one plane. So if I said points A, B, F, that would be the front of this box, so that would be plane ABF. Name a plane in the figure shown. We already talked about one. Let's think, can you think of another one? Well, the top of the box, I could name that plane HEF, but I could also name it plane HGF, or any 3 points among those 4. Are points A, B, F, and E coplanar? So let's locate these points, A, B, F, and E. That would be this front of the box. And because I can kind of join them in a rectangle, then yes, they are coplanar. Are points A, B, C, and G coplanar? Well, let's locate points A, B, C. A, B, C would be kind of this bottom of the box, but G is up here. So I can't make one parallelogram around all 4 of those points. So no, they are not coplanar. This can get a little tricky though. Let's look at points H, E, B, and C. So I have HE up here in the top of the box and BC here at the bottom of the box. But they are coplanar because I could actually join them with a parallelogram kind of going diagonally through the box. So let's take a look at another example. Are these points collinear? So you need to think in 3 dimensions. So think of this plane M as a piece of paper, and think of line AE as a pencil that you kind of jammed through the center of the paper, where point A would be above the paper and point E would be below the paper. And then line BD is actually on the plane itself, so lying on the piece of paper. So let's see, are points A, D, E collinear? Well, if you look at A, D, and E, well, AE is that pencil that you kind of jammed through the piece of paper, but D would be actually on the plane itself. So I could not lie one pencil and cover A, E, and D all at the same time. So no, those points are not going to be collinear. What about DCB? Could you take a pencil and lie it on top of BCD and cover those points? Yes. AEC is that line AE that you kind of took and put through the piece of paper, so you could take a pencil and cover all those 3 points. So yes, those are going to be collinear. Line FBD, well, BD is on a line, but F is not, so that would not be collinear. And plane MCF, well, this is kind of a deceiving question because they're using M in an incorrect way. M is not a point, it's a plane. So you'd have to say no because M is not a point. All right, let's take a look at some more examples. Are the following coplanar? So number 12 says points Q, V, R. Well, if I locate the QVR, that's like the front of the box, I could put a piece of paper over that and it would contain all those points. So yes. And remember, any 3 points are going to be coplanar. So it doesn't matter what 3 points I name, I could put a plane through that. Let's take a look at lines. What about line XW? So XW would be on the back of the box. And line UV would be the front of the box. Well, those 2 lines are parallel. I could place a piece of paper and it would cover those lines. So yes, those would also be coplanar. Let's look at points X, V, R, and T. So X, V, R, and T, again, this is one of those examples where XV is a line, TR is a line, and I could slip a piece of paper kind of diagonally through those. So yes, those would also be coplanar. What about points U, V, W, and S? Well, plane UVW would be the top of the box, but S is all the way down here. So no, I could not put one piece of paper through all those points. And what about line RS and point X? Well, again, this is really like just saying going through 3 points R, S, and X, and any 3 points are going to be coplanar. So yes, those would be coplanar. Let's take a look at some more examples. B, C, D, and F. Well, B, C, D, and F would be all on plane M, so yes, those are coplanar. What about points A, C, D, and F? So AC would be on a plane that would kind of go through plane M, but D and F are on plane M, so no, those would not be coplanar. A, C, E, and F. Well, A, C, E are all on one line, so I can really think of them as only 2 points because I only need 2 points to designate a line. And then point F is over here, so I really only have 3 points here. So yes, I could say that A, C, E, and F could make up a plane. Well, B, E, A, I don't even have to look at those because any 3 points would make up a plane. So yes, they would be coplanar. And M, C, B, again, that's a little bit of a trick question because M is the plane. So C and B are on the plane, but M is actually the plane itself, so it's kind of a strange way to ask the question. So I would have to say no, only because they're calling M a point, and M is not really a point. All right, let's talk about intersections. So an intersection of a plane M and line AE is where do these meet? How many points do they share? So think of plane M as a piece of paper and line AE as a pencil going through the paper. What points do they share? Well, they would only share point C because that's the only thing that would intersect between M and line AE. And what is the intersection of line AE and line BD? So think about if you could put your pencil on line AE and another pencil on line BD, what would they share? They would share point C. So the intersection of a plane and a line is always going to be a point, and the intersection of two lines is also going to be a point. So after you watch this, you should complete worksheet 1-1. And remember, as you're working through it, if you have any questions at all, please ask.